Hi, you can hear me, Ivan?
Yeah, and you?
Oh, okay, good.
Can you hear me?
Yes, I hear you too.
Okay.
Hello.
Hi, Gordon. Let's see. Hi, you can hear me, Ivan?
Yeah,
Oh.
and you?
Oh, okay, good. Oh, that's the live stream on the other. Can you see my screen?
Yes.
Yeah. Okay, good. Hello, everybody. Can you hear me? It's hi.
Hello.
Yes, we can hear you just fine.
Okay, that's good. Well, it's 6 o'clock, so I guess we should start to make sure that we are on time. Welcome everybody to this this tutorial on using games to improve the engagement of students in software engineering courses. Today we're going to show you some results of a project that's called Impress. That's an, well, it's almost finished, an Erasmus Plus project that we started in 2017 till 2020. And it's a project where we've worked on the development of tools to improve the engagement of students in software engineering. So I'm first going to introduce a little bit what the project was about, what our goals are, and then we go to the agenda. And then we have 3 slots where you can actually see what the tools are about that we've made and try them out a little bit for yourself. So first of all, as I explained, it's an EU-funded project that is funded by the Erasmus Plus project, and it ran from 2017 to 2020. And partners of this project were the Open University of the Netherlands, the Utrecht University, the Universidad Complutense de Madrid from Spain, the Universitat de Passau from Germany, and the UNESCO ID Center in Lisbon, Portugal. So, well, this project is about software engineering, and in more specific, teaching software engineering to students. And we know that software is everywhere. It's in most of the devices that we use nowadays. It's in our cars, it's in our phones, it's in our fridges, it's everywhere. And well, to just quote this famous phrase from Mark Andreessen, that in short, software is eating the world. So software is everywhere. But unfortunately, software failures are also everywhere. There is a study that was done by the Software Fail Watch that actually goes through all the news that you can see worldwide. And they see what failures have happened in software and who were the victims of those. And they actually found that in 2017, for example, there were 3.7 billion people that were somehow involved in software failure. And this costs around $1.7 trillion in assets. So there is a lot of software failure going on that's actually costing a lot of money. So the other thing is that the consequences of failure are getting bigger. Since software is now everywhere and we actually depend on it, if it fails, there is a lot of problems. So the consequences of failing software are getting more, having more impact in our society. So there's even people that are talking about the coming software apocalypse, because the amount of failure that we're facing and the amount of money that these failures cost, they might be more costing more than we can actually make a profit of software. So we need to make sure that we look at the software engineering stakeholders and decide what are we going to teach our students. So if we look at the stakeholders, there's basically the customers, the users of software that obviously want to have quality products without a lot of software failure. Then we have companies that make software, and these companies just want to make a lot of money with the software they make. And then we have the engineers. And the engineers, they want to program their solutions. And looking at all these stakeholders and all the needs and desires they have, we have to find out what should we teach our students to make sure that everybody can get out of this what they want. So there's many software engineering books. There's 2 pictures here on the most famous ones that I think are used in many courses worldwide on software engineering. And there's a lot of text and a lot of topics in these books. And what we normally see when we use these books to teach our students software engineering is basically this. Students get bored because there's a lot of text and there's a lot of theory about what software engineering is, requirements, testing, version control, etc. So students get really bored by learning all this material, and they don't get the knowledge they need to get good software engineers that produce quality software. So the thing that we see is that to teach the students software engineering, this goes beyond programming. We can have, and there already exist a lot of tools that actually make learning programming fun. Yeah, we have Scratch and we have, well, even Lego here, you see it on the slide. In the early days when children are young, we can give them tools that make programming and learning it fun. Now we can create something and we immediately have something that we can run, and we can solve nice puzzles and we can immediately see it work and we can show it to others. And we can have different solutions, one that works faster than the other, for example. So this is fun. But if we go beyond programming and look at the whole area of software engineering, there's a lot more we need to know. We need to know about different processes in which we can develop software, like waterfall, iterative, agile. We need to think about requirements engineering, architectures, design patterns, UML, refactorings, testing, formal specifications. There's a lot we need to learn when we look at software engineering. And all these topics until now, until we have finished the results in this project, were not too much fun to learn. So what we have worked on in this project in Press for the last 3 years is trying to make games and invent ways that we can get students to get more involved into learning some of these topics and actually have fun doing it. So the gamification tools that we have developed in the project are, there's 3 tools, and the coming sessions that are coming, you will see all 3 of them. And we have a tool that is called Formal Z. It's a tool that we made to make learning formal specifications fun. So writing formal specifications can be boring, but if you can make it into a tool and actually challenge students to solve nice games and play a game while doing it, you can actually make it fun. So that's one thing we've done, Formal Z. The other tool that we have worked on is Code Defenders, which is a tool that makes learning software testing fun. So it's a tool where students can play against each other. So some students have to defend the software and try to find errors in there. And the other students have to attack the software by putting errors in there. So they can play a game and try to see who wins. And then the final game tool that we made is a quiz tool that we can use to have a whole bunch of quiz questions in a repository that teachers can use to engage students that way. So if we actually have done another study, which was presented also in this conference, that shows that using quizzes in your education actually makes it more fun for students, and we actually could see that it engages them more. So we made this Impress quiz tool that helps teachers to easily create quizzes for different topics of software engineering. So this is basically a summary of what we've done and what you're going to see now in this tutorial. We will start with the gamifying of teaching formal specifications with Formal Z. Then we'll look at the Code Defenders for testing, and we finish up with the quiz repository. So I think we can just continue with the first item. Vishnu, Ivan, are you ready to take over my screen and start with your part of the tutorial?
Hi, so Vishnu here. Ivan here as well?
Yeah, I'm here.
Oh, okay. So hello, everyone. Thank you very much, Tanya. So somebody has a question, why is that? Well, good questions. It might be inspired by the Z formal specification language. So somebody thought it was that's the reason, but that was not really the reason. I think it was because that is about formal specification, and the addition of Z is just some kind of popular additions in the gaming world. So we just call it Formal Z just to make it sound a bit more gamey. All right, so I'm going to copy a number of links. So it's not. It's not really. No, it's not a Z specification language. That would make things a bit more, much more complicated actually. But I will get into that a bit later. So I will pass two things into the chat. So the first one here is a demo link. So you can go to that link and then register and then try Formal Set yourself. And there is also this link here that links to a user, well, a very compact user documentation about, well, mainly about what kind of blocks do you have to later on build formulas. So Ivan, is that the idea that I start first, or is it that you start first?
No, you can start first with the description of the game itself, and then I can just show the backend, how to use the Formal T backend to create some problems, and then let the people play some of the problems that we already created.
All right, cool. I'm going to do screen sharing. Hold on a little bit. Okay. So can you guys see my screen?
Not yet. Just your webcam.
Oh, yeah, okay.
Now it's coming.
Yeah, how about now? You can see it, right?
Yeah.
Okay, that's cool. So formal set. The idea is to learn how to write formal specifications, but then through a game. We can, I think, a bit of motivation. So why bother in learning formal specification? Is it just something from theory, or is it something that is useful in practice? So actually, it's something that is very useful in practice. So firstly, well, maybe a bit more old argument is that if you have formal specifications of your programs, then you have one source of truth. It defines exactly what correct program means, so that both developers and testers can look at this document, can look at the specifications as reference. So that's one thing. But a more practical use is actually in quality assurance in testing. Because then you need to test your programs and you have a reference what mean corrects. And also if you go for automated testing, and then typically you will generate a lot of tests, but then it will be very practical if we have specifications, so you do not have to write the expected output one by one. That's very useful. The old argument against formal specification is that it requires special mathematical training, like you have to learn Z, that has been mentioned before, but Z is a very mathematical language, it's alien to many programmers. But it used to be like that, but it's really, it does not, it's not like that anymore, because nowadays many programming languages are actually very expressive, and you can just write your specifications in, for example, in Java. So I have here an example. In this case, we want to specify some program, let's call it get maximum, to get the maximum value of an array. And then here we can write just the preconditions of the program, for example, saying that the length of the array should be non-zero. And here we write post conditions that involve quantifiers as well. And all the code here is written in Java. So the old argument that you need mathematics, you need to know, well, special mathematics is not, it doesn't hold anymore. What is still true is that the perspective is very different. It's not necessarily the case that when students know how to program, and they do, and then they suddenly excel in writing specifications, because when you write programs, then you tell computers what to do. But when you write specifications, then you are not telling computers what to do, but it's more telling the computers what will be the right input and the right output. And for some reason, this is pretty confusing for students. So it needs some training. They need to do that. But the problem is always that if you go to class about introducing formal method, and I think as Tanya already said, is often experienced as a bit boring. So we came up with the idea of let's develop some game to, to invoke some engagement from students. So you can see here the screenshot of formal set. The idea of the game here is borrowed from tower defense game. If you know that, where you defend a tower, but in this case you defend a CPU. That will be a representation of a program. And here you can see an informal description of what the program is supposed to do. And then we are supposed to, build our pre and the post condition that capture the informal description, but then formally. So let's take a look at a bit, closer. So imagine a simple example program whose informal description is just like this, a program called min. It takes two parameters, x and y, and is supposed to return the smallest integer of the two, assuming that the two numbers here are non-negative, right? So this is just informal. And the task for the student is, okay, so now you have to express this formally. You write formula that express pre and the post condition. So I'm going to show you for the precondition because it's pretty easy. The formalization of this part here is simply that x should be at least 0 and that y should be at least 0, as simple as that, right? Now, once you figure it out, you can write it. But what is more fun is, of course, if you write it inside a game. So here is then the, again, a close-up screenshot of the game. This is the program, the CPU that you have to defend. You see here wire coming into the CPU and wire coming out from the CPU. And later you will see a representation of data packages that coming in and coming out from the CPU. And some of those data packages are read, they are corrupted. And the idea here is to build the pre and the post condition scanner. So that there are the little thing here that's supposed to be a scanner. And the task of the scanners are to mark corrupted data so that they can be shut down. All right, so then to do that, then we click on a scanner. So in this case, a precondition scanner, and then you will see a building pane like this. And then you build a formula. Basically, this is the abstract syntax tree of the formula that you want to build. And here you can see the components to build the formula. For example, for the operators, the n and the greater or equal, or the variables x, y. And you see, for example, here the x and 0. And this is the operator x is, greater or equal. And you can recognize here the operator n. And everything must begin by a begin node here that you recognize here. So you simply select a component and we drag it from the right type to the position in the building, a pane here, drag other components and then connect it with wires like this. And then we build our formula tree. And then here, once you're ready, then you will see the textual representation of the circuit here. Then it says here, the represented formula is, as you can see here. We'll do the same with the post condition, and then we are ready, basically. Then you can just hit, this little button here, next wave, and then the attack will begin. Then you will see critters like this one here, start to go to march into the CPU, and then later on to march out from the CPU. You see some of them are red, some of them are blue. The blue are the good data. The red ones are the data that are corrupted. So they are data that are incorrect. So the task of the scanners, the pre and the post condition, is to recognize those. So in terms of feedback, when you see the critters here, you can see that there are red. If the red are being marked like this, that means that the scanner is working. It is marking the bad data. But if you see some of the critters, so some of the red, like this one here, this is not marked, right? So it looks like this. Then this is good. This is not good. So it means that there's part of the scanner, part of your pre or post condition that is still still too weak, not strong enough. The good data, so the blue ones, they also give some information. If you see something like this, so blue but unmarked, then everything is okay. But if you see that there are some of the data that the blue ones that are marked like this, then something is not good. It means that some part of your pre or post condition are actually too strong. So you can feel a little bit, well, either your formula is a bit too weak or a bit too strong, and you look for something in the middle. If more detailed feedback is needed, then if you click on the top here, then you can see a counter example actually. Then it gives you a more detailed example of why thing is wrong. And then you can read it and then sort of trying to use that information to fix the formula. Now, having done that, after building the correct formulas, then then we can just hit the next wave again, and then you basically finish the game. You have the correct formula, and you're done. You win. But it's also fun because this is inspired by tower defense game. So CPU defense game. You can actually build towers. So the top that you see here allow you to build different kind of towers, and you can boost the towers, and then you put the towers along the wires here, like here, there, and there, for example, and then try to earn more points. So that's a bit the fun part for the students. Not only that they build formula using the building pane here, but well, you can also play a little bit with the towers. Well, that will be it. If you want to try, you want to play, and this is the link. I think that Ivan will now next explain how to set up the game here from the teacher perspective. Okay, Ivan, that was my part.
Okay. Yep. Meantime, if you want the attendance to play one of your problems, you need to share the link for that specific problem. If not, then I will just share the link for one of the problem that I'm going to show to them how to build it. So
up to you.
Okay, so let's try the example. Maybe you need to let me check how I can take control of the screen.
Yeah.
Okay. Hopefully now you can see my browser. Yeah, can you see my browser now?
Yeah.
Yeah. Okay.
You do?
So
Yes, I can't.
Yeah, maybe you're
yes,
just okay. I'm going just to put a link in this chat for the slides. The slides is just a short handout for the steps that I'm going to follow to set it up and configure Formal Z in our daemon installation. So as Vision said, in the case of Formal Z, maybe now know how it works a bit, the game itself, but we are going to go to follow and to have a look from the teacher perspective how to use Formal Z. So Formal Z is a web application, and the game is a web browse game. So the server that Bizu provided is just a demo server. So afterwards, the conference maybe it's not available, but hold on, because the last thing that I'm going to show you is how to get the an installation and the source code that you need to create your own installation of Formal Z. So as Bizu said, this is the demo installation for the conference. So from the teacher perspective, we need to follow different steps. First of all, when you install a Formal Z installation, you just create you just only have an administrative account, and as a teacher, first of all, you need to join to the installation that you want to use. Then afterwards, we need to create a room, prepare some problems using the syntax that that Vishnu already shown, but later on I'm going to show you the complete syntax for the programs. And then afterwards, you already have a collection of programs, or just to create, or you already created the activities that you want to use for your own classes. Then you ask you ask students to join to that specific room, and then just play the game. Okay, so let me go to the let me just log out from Formal Z. This is the main web page that you arrive when you get into an installation. But if you want to invite a teacher, you need to log in as the administrative account of the installation. So you need to specifically go to this specific URL, admin/login, then just use the account that is configured uh, for the installation. And then as an admin, you only have the let's say the ability to invite teachers. Then teachers, once you have invited a teacher, then you can just move on and then go as a teacher and do all the rest of the task. So just to show you, it's quite simple. Just type down the link. Type down the email address of the teacher, and then you just click send invite, and then you are going to receive an email from the platform. But let me change the view and go to the and log in as a specific teacher. So once I join it to the platform, you can log into the platform, and you have different options here. Although it is possible that you have both roles, here in this tab, you can see the rooms that are more or less. A room is like a classroom. It's just a group of students and yourself as a teacher. So, for example, if this account also participates as a student in one of the rooms that is available in the system, will appear here. But in this case, we are going to concentrate in the teacher UI to deal with and to create some problems for the students. So here you can see some of the rooms that I already created for testing this installation. But to create a new room is quite easy. Just click in the new room, just provide a room name, demo room, just a short description in the just a short description for the room. And here this option is quite interesting, because if I click here, then later on when I create the room, it will take some time. I will later on tell you why. But this is just the new room created. But if you want to invite students to join to this specific room, if you go here to this option, invite students, because I just checked the option for creating a join link, you as a teacher will get this link that I'm going to paste it in the chat too. So meanwhile, I am going to explain how to create the problem. You can join as a student, and later on you can play with the example that I'm going to create inside this installation. In addition, you have also the option, because this link is more or less like, it is not public, but let's say that it's this huge, large X number, so it is not easy to just get into that room very easily. But if you want to have precise control of how to join students in the room, you can, instead of check this option, just check out this option, disable this option, and then later on, instead you have to add manually one by one all these students. For now, I'm just going to keep this option enabled so you can join easily. So now, how to add a new problem? We just need to add a problem clicking here, and then you have these options, these different sections. Let me go back to the slides because that's maybe need a bit longer explanation. So as I've already shown to you, and we're going to get back to that, to the UI, to add to create the problem itself. And there is, let's say in the UI, there's 4 sections: the problem header, the pre and post conditions, and then just a problem description. As Vision already said, the problem description is for the students. It's just a short description about the problem that the students needs to solve. That is more or less the context of the game that is provided to the students. Then inside the in addition to these core elements, we have additional elements like the difficulty and the amount of intermediate problems. This option, in addition to just play one problem, you can offer the students to play several problems. In particular, you can offer them to play different problems in a row. So let's say that you have a complex problem that you want to give the students, but instead of just giving that specific problem at the first place, you can create few intermediate problems that the student need to go through them until and actually finish them before they can get into the main problem. So that's the additional elements. Also, the game elements. Visual also gives a short, brief description about the gaming elements. There are some lives around that you lose some lives if you don't mark the sparks, the packets that Vision said properly, because you mistyped the pre or post condition, and also the available money that you have for playing the game. So these are gaming elements. It's not specifically related to the formula and to the problem itself, but it makes you, and also it allows you to tweak the difficulty of the problem or the gaming part. Let's say, for example, if you don't provide enough money for the students, for example, students need to spend some money to use the blocks. So if you don't provide them enough money, it is more complex to play the game, because also when they try to discover if the pre and post conditions are right, they also have to spend some money. So this way you can also, let's say, control the gaming part and the challenging part of the game. And also you have also some visibility options to create. Let's say that you can create a problem like an assignment. Sorry. So you can give them an available and due dates to control when the problem is available. So regarding the syntax for the header and the pre and post condition, I just put this couple of slides just to you have some reference material for if you want to use Formal Z. But let's go back to the room and create a new problem, so you can also try that problem. So as I said, there is this problem header. This we need to put here like the method signature of Java method without the public or private or protected, and also without the return type. So I'm just going to copy some of the examples that I have available. So this is just the header of the function. The problem description, as we already said, is like the description that you're going to see when you refresh the room after I created the example. Then the precondition in this case is just to this example. This problem is that is to allow the students to define the pre and post conditions for to calculate the maximum of two numbers. In this case, the precondition that is used to test and to check the solutions of the students is this one. This is not it's not too complicated, but also if you have a look to the slides, you can create more complex formulas with existence quantifiers and for all quantifiers. The post condition in this case is also not so complex. So if I just paste it here, the solution of the for the post condition, and then these, as I said, these are the core elements and the core attributes. And then you can also define this difficulty section. In this case, I'm going just to say that it's quite simple and that I don't want to allow, let's say I want to allow you to go directly to the game itself. Also, in the advanced options, you can control and to add more, tweak more parameters like the amount of lives that you have and also the amount of money. Right now, I just going to leave the default options. Then, so I'm just going to create the problem. So hopefully, hopefully you now can, if you already joined to the room, yeah, there are a few people here. So now you can just go to the active problems. Actually, as a teacher, you can just try it out. So you can just click, as a teacher, click in the play problem. You as a student, you also have these play problems, so you can go there and try it out. So that's I mean, that's the easy, I mean, the most of the things that you have to do with Formal Z. I don't know why, but this room is not created with all the properties. I'm going just to show you one of my other rooms because I want to show you some data that you can get out of the example. So I already have some room here. This one, I just tried out with a couple of mock users. After the students play, you can get, let's say, once you created the puzzle, you just students just get into the platform, play, but you want to know what is going on. It depends. You may want to know what is going on after they have played. For example, if you just created the activity as a kind of assignment, but in a scenario that you are in a lab with the students and you want to know what is going on during that game session, because you are going to, for example, let the problem to let the students reflect about something that you're going to talk about next, or in a scenario like this one that you are in a remote location, we are not in the very same location, you want to also to know what is going on. So in this case, Formal C offers two options. You can get simple statistics from this UI. You can just have access to these high scores with the students, and also as a student, you can get this information too. The student is like a kind of a leaderboard. My scores if I just played, and also some very basic statistics. So how many students have played, how many time, the average time spent for the game, and you can get some graphs like these ones. And also you can check exactly how many students and which students have completed the puzzle here in this tab. If maybe there are some students that they just try the puzzle, but then later on just quit and they don't finish. But also these stats are just gathered during the gameplay, but you can only see afterwards, after the students finished. But there is also the option to to have access to a real-time dashboard to know what is going on during the gameplay. So I don't know why the room that I created is not created properly, but when you create it properly, it also for the specific problems you get this specific link, dashboard link. So if I click in this link, a new oops. A new browser pop-ups, and you get this dashboard that now is empty. But if I just go a little back in time, oops, maybe there's there is an issue with the link that I just created. Let me check. Yeah, this one. So usually when you just click the link, it jumps directly to this dashboard. And here in this dashboard, I'm going just to make it a bit smaller. You can get some feedback about how the students are performing the game. So, for example, how many times the students have tried to create some pre or post condition, how many students are actually playing, and also different, let's say, number of waves of this that the student have tried. The waves are how many times have you tried the pre and post condition to check if that works. So also when you get more data, because this is a session that is a bit old, but I can show you a session with more data. You can get this kind of graphics where graphs, well, you can have a look to how many money have the students spent. This way, for later sessions, you can just make some tricks and then adapt the money you provide them to make the problem a bit more difficult. Also, how many towers they require to build to add into the game to create to actually solve the problems. How many lives they've lost during the gameplay, and also there is the timing dimension, so you can see here. Different waves that I've been sending and how many time I've spending during the different waves. Also, more interesting when you are a teacher and you want to help the students, because maybe students get stuck just providing some defining or refining some of the pre and post conditions. You can go down to this specific part of the UI, and you can see the student and also the pre and post condition that they have sent to the system. Every time a student just send one pre and post condition to the system, you are going to get this new log entry, so you can go here, have a look how the students are doing. And for example, if some students just get stuck, you could just in the case of a lab, you go there and ask her for or help her about or check it out what is the problem. But if not, then in a situation like this one, you use Zoom or whatever like conference tool to set up a break room and then help the students. So that's more or less the idea of the analytics, that you can get real time. This data is collected during real time. Unfortunately, I don't know why, but the room that I set it up for the session, it doesn't have access to the dashboard. That's a pity, because the idea is that later on you are going to play that game. So we will. My idea was just to have access to the actual data you are going to send to the system, but at least you can grasp the idea of what kind of data as a teacher you can get from the system to understand what is going on to using the formal G. So let's go back to the slides. Well, as a student, as I said, just provide the link, like the link that I already provided to you in the chat, or just invite one by one. So after the students join, maybe you already started to play with the game. So as I said, how you have these two options to get some data afterwards or to get some data meanwhile, if it is all the things are working properly. But that's the idea. So the last thing I want to tell you about is, okay, so let's say that this is just a demo installation, but you want to create you want to have your own installation of Formal C. So how can you do that? So you can go to our project website there and then get all the information and documentation there. But also we also provided a couple of helpers to set it up an installation of Formal Z, depending on your needs. If you don't need to have the to the near real-time analytics. Let's say to have these fancy dashboards that they show you, you only need to go to this second link and then go there and follow the instructions to set it up. Maybe just a demo installation in your own laptop, or to use that as a basic instructions to create your installation in an actual real server. But if you want also to have the analytics, then you need to install, before installing Formal Z, you need to install Rage Analytics. Actually, you need to install this installation of Rage Analytics. The Rage Analytics is a result of a previous project, of a previous H2020 project, but we just modified that platform for the needs of Impress. So you need to install this specific branch that is also container based, so it is not too complicated to install and to follow the instructions. And afterwards, you can install Formal C and have your own installation of Formal C. For example, I just to finish my part of the presentation, I'm just going to show you that I have here in my laptop similar installation of Formal Z, and you can just play with and try it out before actually installing in an actual server. So that's all on my part. Vishnu, maybe you can take control again. If I remember correctly, the idea is just to allow all the participants to play one of the programs, just to grasp and to test some of the Formal Z examples if you didn't already tried. So
yes, I think that the link that you gave, I think that works with one problem that you created, no?
Yeah. That's mine. That's the link to join to the demo room that I set it up live. So if you go there and join as student, actually I could see that there are a few people there. So you can try it out for a few minutes, and then later on we can get back and answer some questions regarding Informal Z and also to let me check it out if in the demo room there are more people. Yeah, there are a few people. So if you try it out, let's say for 50 minutes, and then later on we can get back to answer some of the questions that you may have, or at least have a look to the results. Okay, guys, so if you have any issue, just raise your hand and then ask some questions or ask. Let us know if there is an issue with the problem, or if you get stuck in some part of the example that I've set it up. No, there is already. I guess it is your business that you already finished the game.
Yeah, not the best score though.
Maybe meanwhile you're playing, if you're just playing, try it out. It is better to have a look by yourself. But maybe I'm just going to show. Let me play the game, so I can just show you how these actually work. Or so maybe I can just help you with some of the you are getting issues playing. So this is just the main menu. I'm just going to disable just these sounds just to avoid any sound during the play. So let me join just as a student, maybe, because let me try it out as a student, just to I'm just going to copy the link. I don't know why this rooming is not created properly, but let me just use the link I provided to you to join as a student. Okay, so now let me go to the play. Okay. I don't know why. Bisno, you could play through the game, right?
Yeah,
maybe there is something in my browser regarding some cookies or some stuff, because I seems that I can play with this browser, but I can change to maybe you can share your screen and play it again, right?
Yeah, let me try. The problem doesn't occur. Hold on. Well, you're not the only one. Hold on.
sorry, Richard, to hear about that. I just maybe just did something because I just set it up for the conference, but we just tried before the session. That's what usually happens with live demo. Sorry. Yeah, I'm sorry. Sorry to about that. I don't know what was the issue, but hopefully, if you got interested, you can go to the GitHub place and then try it out by yourself. And then drop us an email if you have any issue or problem with installation. And well, that's all from my part. Tanya, I guess that we are almost on time for our slot. So maybe we can also switch to co-defenders and Gordon. So
maybe there are some questions from the audience.
yep, we are happy to answer.
Do you have a different room set up that you can go and play and show us how it works right now?
Yeah, let me check if I can just share a different room, because I don't know if it is just a room or it is a different thing related to the demo server.
Just try it on different room. It has the same problem.
So yep, seems that there was an issue with the server. Sorry about that. Any other questions?
Well, if there's no more questions, I think we can go to the next item, or maybe we can have a little break. Is that something that people are in need of, or shall we just continue?
Well, personally, I do not mind some break. Can use some tea.
Okay, so shall we then do a 10-minute break, and then we continue at 7:10 with the next item?
I think we should ask Gordon as well, because he's next.
I'm fine as long as the audience doesn't run away and not return after the break.
That's a good point.
That is a good point. Yes, I did not think about that. I always take the presence of my students after the break, so they come back, but I don't know about you guys. Well, you do not want to miss our results on Code Defender, so you will come back, no? Nobody says anything. It is like a lecture with my students a little bit. This is true.
I'll be back.
I'll be back too.
Okay, good, good.
Okay. Yeah, Julie.
I'll be back too.
Okay, well, then let's have a little break and then we'll see you at 7:10.
Okay, see you.
No, there's a break.
I think they're ready. I did 18 minutes. And that's what. If you have not rotated around, do that. What's very dark? Probably is the ones in the front are not very brown. You didn't bring it, did you? It's like you. Mm-hmm.
So let's see if everybody's really back.
Yes, really
Oh,
back.
Good. Good.
I'm back.
I've been having problems with my feed though, so I've been turning off my video. Sometimes I miss about a second or so. But I am here.
Okay, good.
I am eating, so I will close the video. It's lunchtime here.
Okay, well then, Gordon, if you want, you can take over the screen.
All right. Can you see my screen?
Yes.
Oh, the slides, actually.
Yes.
Okay. So I'd like to introduce Code Defenders, which is a mutation testing game. So I'd very briefly like to start by explaining what mutation testing is, just in case you don't know it. Please feel free to interrupt me at any point to ask questions. I'd be happy to answer them. So mutation testing is a technique in software testing that has been around for a while. It's something we use in order to assess how good a test suite is, or in order to improve it. And the idea is that we have some program under test, like our absolute value function here. And then we have some test cases for our program, such as this test case written in JUnit format, which calls our function with parameter 42, and then it asserts that the return value is 42 as well. If we run this test on our program, the test will pass, and so we have gained some confidence that our implementation is correct. But the question is, how well have we tested this program now? And that's something mutation testing can answer us, and it does this by creating so-called mutants, which are artificially broken programs. They're artificial defects where we, for example, systematically replace individual operators or do small syntactic modifications. So for example, I replace the greater equals operator with the less than equals operator. And if I run the same test case on that so-called mutant, the artificial defect, then what will happen now is that on the mutant, this if condition will no longer be true. So the execution will lead to this return minus x. It will return minus 42, and thus the test will fail. And so we've learned something. We've learned that we're actually testing something useful. We can distinguish between the program and this mutant. And there might be other mutants. For example, if I replace my minus x with a plus x, if I run the same test case on that mutant, the test case will pass because 42 is greater equals to 0, so it'll return 42, and that's great. But it doesn't actually cover that part. So with that, we have identified a weakness in our test suite, and mutation testing guides us in how to improve our test suite. We know if we make this mistake, our test suite will not detect it, so we need to add a new test case, whatever that test case might look like, such that if we run that test case on the original program, then the test passes, and if it runs on the mutated version, then the test fails. Right? So mutation testing guides us to improving our test suites because it tells us where we've missed parts, potential mistakes, and then we can write new test cases that check these bits. So that's the idea of mutation testing, and that's the central aspect of the Code Defenders game. Code Defenders is a competitive game. There is a Java class under test, so the central aspect of the game. So we always have one Java class that we're testing. I've used the absolute value function again from my previous example. And then there's two player roles. There's attackers and there's defenders. What the attackers have to do is they have to produce mutants. So they're trying to create faulty versions of the program under test. And the faults should be as subtle as possible in order to identify holes in the test suite, and the test suite that is produced by the defenders. So the aim of defenders is to write test cases for the class under test. And we're using Java code, so the test cases are written in JUnit style. Now, these test cases produced by the defenders are executed on the mutants produced by the attackers. And if the attackers succeed in producing mutants that are not detected by the test cases, then they have succeeded in identifying a weakness in the test suite, and so they score points for that. On the other hand, if the defenders succeed in creating tests that detect some previously undetected mutants, then the defender scores some points because they have managed to improve the test suite. If you know mutation testing, you know there is one catch with this, and that's if you just syntactically modify a class, that doesn't necessarily mean that the program is semantically different. So if we return to our absolute value function example, and we mutate it, for example, by replacing our 0 with a 1 or the greater equals operator with a greater than operator, there exists no test case that we can create that would be able to distinguish between the original program and either of these mutants, because +0 is the same as -0, and we won't be able to distinguish the two. So in classic mutation testing, that is kind of a problem because it skews your mutation scores and potentially waste time investigating equivalent mutants. We have integrated equivalent mutants into the gameplay. So when a defender suspects that a mutant produced by an attacker is equivalent, they can challenge the attacker to a so-called equivalence duel. And so in order to do this, the defender needs to have at least attempted to reveal the mutant, which I'll show you in a second. If so, they can say, I think this is equivalent. And now the onus is on the attacker to prove that the mutant is not equivalent. And how do you do that? Well, by writing test cases. The terms killing a mutant, they originate from mutation testing. So this is the actual terms used in mutation testing. Code Defenders is by no means an actually violent game. Using a test case, you can prove that a mutant is not equivalent, but maybe it could also be a strategy to produce equivalent mutants on purpose to lay the defenders astray. So in such an equivalent mutant duel, points are at stake, and if the attacker has to confess, well, actually, this is really an equivalent mutant that I produced here, they lose points. So at this point, no, not quite at this point. Initially, we started off with Code Defenders as a turn-based game. So we had 2 players, one player being an attacker, one player being a defender, taking turns. We extended this because the waiting times are a bit inconvenient in a classroom setting. We extended this to a multiplayer version, which we're mainly using currently, where you have teams of attackers versus teams of defenders. And creating mutants and tests can be done asynchronously, so there's no waiting time involved. And we're currently exploring a new game mode called the melee mode, where it's essentially everyone plays against everyone else in the same game, and you can do, each player takes the role of attacker and defender. So here's what Code Defenders looks like. Let's start as an attacker. So it doesn't look like an actual game, it looks more like an IDE. So it's more like a serious game, really, than an arcade game. What an attacker gets to see is the class under test. So I've got a simple example class, lift, which is a little elevator class, which it has certain properties, kind of take a certain number of people, has some observers, you can add riders, it can go up, down. And creating a mutant consists of editing the source code. So for example, I can create an artificial fault by replacing a variable with another one, and then I click attack. And what happens is that my mutant is compiled. There are no tests yet because this is a fresh new game. So my mutant survived. You can see there's a mutant in here. The red icon denotes that the mutant is still alive. And I also can find the mutant in my mutant table and see the actual diff underlying this particular mutant. Okay, we can also maybe do some more mutation so that the defender side becomes more interesting. I need my defender window. So this is how the game looks like from the defender point of view. I see the code of the class under test on the left-hand side, and I can't edit it. Instead, my code editor allows me to write JUnit tests. What I do get to see is locations of mutants produced by the other me, right? So I'm simulating being two people right now. So the other me, the attacker, created some mutants in line 40 and 22. And now I can attempt to create tests that reveal these mutants. For example, I create a new lift, and let's assume I want to test whether the capacity is correctly initialized. So I would call the corresponding constructor and then write a classic JUnit assertion that checks that the capacity is actually 20. Get capacity. I click on defend. Now the test case is compiled, it's executed on the original program to make sure that it's a valid test, and then it's executed on all the mutants that it covers. We see two changes now. The first one is we see some green highlighting of the parts of the code that have been covered by this. And this particular mutant is now grayed out because it has been detected by my particular test. We also get to see mutants. As a defender, however, I only get to see the location of the mutant. There's actually different modes of difficulty, which can be varied. But by default, in the hard mode, you can only see that there's a mutant in a particular functional line. And only once you have succeeded in revealing it with the test, we can have a look at the test that detected the mutant, and we can look at the actual change now that we have revealed it. Okay, so if I maybe return to my attacker window, I get to see that things have changed, that defenders have taken some action here. There's some code that is covered. And I might, for example, let's see, we need a mutant that we can claim for an equivalence dual. So I'll create a mutant in here, knowing very well what I just did. So it's cheating, but this mutant survived and it's covered. It's covered by a test, so it gains points. We can see that in the scoreboard. Currently, I'm the attacker Gordon 2, so I've got 3 mutants, which have scored a total of 4 points. Points are based on the number of tests that the mutant survives. And switching back to my defender hat, what I can now demonstrate is that we have a mutant here that we have attempted to detect. So we've covered it with a test case. And if we believe that we have thoroughly tested that function and that mutant might be equivalent, we can now claim it to be equivalent. Ask us, are we really sure we want to do this? The mutant is now, the color is changed to denote that this mutant is flagged as equivalent. And if we switch back to our attacker view, the attacker is not allowed to do any further actions, create new mutants, until they have resolved the equivalence dual. And that consists of writing a test. As the person who created the mutant, we can, of course, have a look at what actually the change was. So we can create a mutant and just put 30 people on that for our capacity, and then assert that 30 people can fit into our lift. Right, and if we believe that this test will reveal that this is a non-equivalent test, we submit it. It compiles, and I just won the duel because that mutant is now detected, and I can see in the scoreboard that I have won this one duel here, and I have gained a point because I have just won this duel. If I had lost the duel, then I would lose all the points associated with that particular mutant. Okay, so this is the basic gameplay. Now there's 2 things I'd like to do, and feel free to tell me what you prefer. There's some experiences from the way I've been using this in a software testing class. And the other thing is I'd like to give you a chance to try it out. So unless you interrupt me, I'll start by giving a couple of stats about how this worked in practice, and then I'll set up a game. And we'll probably just do a single game where everyone can compete, so we can actually have a bit of competition here to see how good a tester everyone is in here. So the stats I want to show you are based on a course I taught at the University of Passau in, was it 2018 or was it 2017? If only I knew. At the time, this was a course open to master and bachelor students, 180 registered for that course. I could only accept 120 because that's the number of people I could fit into lab sessions. And I integrated Code Defenders at the time by having students attend a 2-hour Code Defender session every week throughout the semester. I have since then slightly relaxed the requirements and changed a bit, so they now play Code Defenders only for a certain number of weeks and then have some other tasks. The way this worked is that in each of the lab sessions, I would take attendance of the students actually there, then allocate them to a number of games of 3 to 5 students per team on similar classes, similar Java classes. These Java classes were initially quite simple, and then the complexity was gradually increased over time. The students alternated their role. So one week they were attacker, the other week they were defender on different games. And their contributions to the games were counted as towards their grade. I'm going to show you how exactly we did this. So the first thing that's probably of interest is to see what students actually do if you force them to use Code Defenders. And what they do is they do produce reasonably good tests. So in a regular lab session, if you consider all the time it takes to set up the games and explain the code and for them to get familiar with the code, there's probably about 60 minutes of actual playing time left. And then typically in that time, they would write about 20 tests. These are very good tests usually, or on average about 36 mutants. So over the course of the semester, they took part in, I think it was 10 sessions where I actually graded, and each of the students on average wrote 120 nice tests and 160 very good mutants. The interesting thing is looking at the improvement over the semester, and one way we can look at this is by looking at the quality of their tests, for example, in terms of coverage. And we can nicely see how initially they were pretty clueless about what to do. And as time progresses, the tests they produced achieved higher and higher coverage, even though the classes they were testing, the Java classes they were testing, also increased in complexity. And by the end of the 10th session or so, they were all kind of very good at writing test cases that explored the behavior of the Java class on the test quite well. We also compared how the performance in the game relates to their overall exam grades. And you can see that there is a clear relation between what they do in the game and their exam grades. Right? So it's not just messing around. It actually forces them to do useful things. And the students who are more engaged with the class will engage in a different way with the game than the students who are less engaged. And finally, we also surveyed the students to find out what they think about this. So I'm not going to go through all the questions, just to highlight some things. Like the first question was, did they enjoy playing Code Defenders? And overwhelmingly they did. Some of the students on this side of the scale enjoyed it initially, but then at some point got annoyed with it or with the performance of the other students they were competing with if it was too simple. When asked whether they generally like writing tests outside the game, there's a clear difference, but they still generally, the answer was slightly more positive than I would have expected. But then again, asking students in a software testing course whether they like writing tests, of course, will lead to certain bias. Generally, one thing we observed was that they think they believe they learned very useful skills while playing as defender, they don't think it to the same degree when they're playing as an attacker. So there's more people who think they wasted their time mutating programs. And we observed that usually what they do is they randomly try to type in the editor without thinking about what they do, how it relates to a test suite. So we've tried a couple of things in order to address this problem. One of these things being the new game mode, the melee mode, where each player now is an attacker and a defender at the same time. But overall, the experience was quite positive. And to repeat this survey in the years since then in the course, and the result is always pretty much the same as this. Students do tend to like it. There are a number of challenges when you want to deploy a game like this in the classroom. There's the whole business of managing the classroom. Students will arrive late. Students will arrive in the wrong session. Students will skip one week and join a different session the other week. So there's lots of things you have to handle on the fly. Obviously, you want to only, since it's part of the grading, you want to make sure that the students are actually there, and you want to ensure that only students you can actually control are taking part and not people from outside. Of course, that's a different challenge nowadays, considering the COVID situation. There's the question of managing the actual games. You need to monitor what they're doing. Are they all engaged? Are there problems? Then there's the whole point of course management. So you need to decide what are suitable Java classes to consider for testing. How do you ensure that students remain engaged? And finally, there's the question of how do you assess the performance at a game? Because the score, or whether they won or lost the game, will depend on who they competed with or who was in their team. And obviously that shouldn't be part of what they're assessed for. We want to assess their performance at writing good tests, independently of what other people did in the same game. Okay, so rather than showing plenty of slides of all this, what I'd like to do is show you the administrative interface, which should be in one of the many tabs here.
Can I ask quick questions?
Yes, please.
So,
please do.
Thank you. Could you go back to the slide where you showed the graph where the grade versus the number of test cases? Yeah, this one. So I'm just a little bit curious. Does it mean that those who got good grades wrote less number of tests?
So in the German system, 1 is the best grade and 5 is the worst grade.
Okay.
Thanks. Very good point. I didn't think about mentioning that. Okay. So 1 is the best grade.
I see. Okay. Yeah.
Yep.
And the other question I had is when you said that the attacker would change the code, and the defender has to write the code test case to catch that. Did you mention that the defender gets to see what code the attacker changed?
So when you create a game, you can choose the level of difficulty.
Okay.
Here. There's an easy mode and there's a hard mode. In the easy mode, the defender gets to see the actual diffs of the changes. I could just create one, I suppose. So this is now easy mode. And if I create this to, I don't know, 42, and then I need to find my defender window and join this game as a defender. Now I can view this mutant and I get to see the actual diff.
Mm-hmm. Okay.
This potentially is unfair because now the defenders have a slight advantage over the attackers. On the other hand, in easy mode, if I write a test here, then in easy mode, the attackers would get to see the actual source code of the test. In hard mode, which was what I showed earlier, this one here, in hard mode, the defenders only get to see the location, but not the actual diff.
Mm-hmm.
So they have to think about what is the best possible way to test this function without considering the specific diff. And similarly, in hard mode, the attackers only get to see these are the parts that are covered, but they don't get to see how they are covered. So they don't get to see the tests until their mutant is detected by a test. Then once a mutant is detected by a test, the test and the mutant are revealed. Okay, but when you create a game, you can choose whether you want everything revealed or you want to hide some information. In class, I tend to use the hard mode because I think it's first of all, it creates a somewhat fairer setting between defenders and attackers. And I think they have that they simply have to think a bit more about what they want to do about how they want to test the code. Right? It's not just triggered by a particular boundary value that they observe in the diff. They have to have the idea themselves that, well, maybe I should check for boundary values in here. So that's why I tend to use the hard mode.
And just another question I have, I can wait for the presentation to get over, or I can ask now if you allow me.
Please go ahead. Okay,
so thank you. So I'm just trying to understand, not that well familiar with mutation testing. So when the attacker has changed the code, the source code, and you say the defender has successfully defended, do you mean the test case has to detect the change, or just have the code so that it executes the portion of the code that was changed? If I make any sense here.
So the tests they write are JUnit tests. And in order to detect a mutant, the test needs to pass on the original version of the class, and it has to fail on the mutated version. So just covering it is not enough. In fact, if you just cover without detecting the mutant, then that increases the score of the attackers who produced the mutant. Right? So each mutant has a score, and the score is the number of tests it survived. Okay. So every time you add a test that just covers it but doesn't assert anything related to this, you will be helping the attackers win the game.
Mm-hmm. Very interesting. Thank you.
Okay, are there any other questions? Okay, so to manage things in the classroom as smoothly as possible, there is an administrative interface which allows me to do a couple of things. I can create multiple games at once. So typically what I do in a lab setting is I take attendance of the people there and then just copy and paste from my spreadsheet who's there, the list of student usernames who are there. And then I can create a number of games, choose how many attackers and defenders there should be per game, and then the games are created automatically. I can also select that students play the opposite role they had last time, so that in 1 week they're attackers and the other they're defenders. And I can also, and this proved to be quite useful, allocate teams by scores in previous games. So students who performed well in previous games get assigned to the same games, and students who didn't perform so well are also grouped together. This kind of balances the skills of the students within teams, and so you get more engaging games. And it's in particular, if you have a super keen student facing students who are maybe not so confident in programming, then the game might quickly become frustrating for those who are struggling to produce compilable code while the other person is writing wonderful tests. Right? But by leveling their skills somewhat, you get very engaging games of very good students, and you get games with students who might need more attention, and then you can focus during the lab session on the students who need the help. I also tend to increase the size of the teams for weaker students so that there's more students there, and then they can see what other students are doing and try and copy tests others have written and manipulate them. So once you have created games, so I'll just create some games for myself on the lift class, and I don't really care about the other parameters for now. So before the games are actually created, you get a list of games. I only selected 3 players, so there's not much to do here. But sometimes before you actually start the games, you want to shuffle students around and change the roles and do some fine tuning. You can do this. And once you're done with it, you create the games, and then you can switch to monitoring them. And in the monitor, you get an overview of all the active games. You can see when for each of the games, what are the students doing? When was the last action they did in the game? The number of submissions in total points and total scores. And so you can easily spot if somebody is not engaged or if a game is starting to become imbalanced. And then if, for example, if a team is struggling and the opponents are winning, then I tend to join the game on one side and kind of interfere a bit to make the game more balanced again and let them continue. What you can also do is you get a bit of an overview of some statistics. So I can view what each of the players is generally doing, how many games they've played and how they performed and so on. It's just some general statistics about my users. I can get some general statistics about the classes I'm using, because if my code is too complex, then that kind of inhibits the game as well. So I can observe whether the defenders or attackers tend to win more often. There's an option to provide feedback and equivalence mutants and so on. So I get some statistics here. And then finally, there's the concept of a kill map. This is not a term that's exposed to players. It's, again, a term taken from the mutation testing literature. A kill map is the result of running all the tests against all the mutants, and then it's a big matrix. And based on this, what we do is we decide how many of the mutants and tests produced by the players were actually useful for some definition of useful. So for example, a mutant would be useful if it survives at least one of the tests out of a large pool of tests, such that it's not trivially wrong, but it can be detected so that it's not equivalent. And similarly, a test is only useful if it can, in theory, detect at least one mutant. Right? Maybe in that particular game it was used, it doesn't detect a mutant, but by looking at the overall matrix of all the tests and all the mutants, we can kind of distinguish between useful and not so useful actions. And then this is kind of what I use as a starting point to decide on grades. Okay. So I think, how much time do I have? Do I still have a couple of minutes?
17, no?
Okay. I can't remember the schedule. What I would suggest is the following. I'll create a couple of users. So I created a list of names I saw on Zoom earlier, but I see that some people have joined. There's John. Don't know, is there anyone else I've missed? So I'm going to create a couple of accounts. This is on a test server. So I'd like to give you a chance to try it out, but this is on our test version with the current beta version 1.8, which we're planning to release soon. So it's full of brand new features and might break, you never know. Aha, password for user invalid. That did not go quite as expected. Ah, okay. So there's the effect of creating. Okay, I'll do this differently. How about we create user demo 1 and 2, and you just log into random accounts? Or do you want to register? Any preferences?
I don't have any preference.
Okay. So
If you link, then we
yes, I'll post a link in here. So this is our testing server. I think the password restrictions aren't quite as restrictive as they were for formal Z, but it does require some numbers and lowercase characters. If you don't want to use that, just use demo 1, 1, 2, 3, 4, or demo 2, 3, 4. I'll just create a couple of demo users and you just pick one of them. Okay, so I'm going to create a game for my demo users. And the users for which, for some reason, which I'll have to find out later, creating the game worked. If you sign up, you can simply join it. And what I'd like to try is try out the new melee mode game, which is a new game mode, but it would allow you to try both attacking and defending. So I'll just create one single game for everyone to join. Create that game. Now that game is started if you if you create your own account, you can simply join that game number 119. And if you join as a player, this is the melee mode. This is the new game mode we're trying. In the melee mode, there's no teams. It's every player against every other player. And maybe I should demonstrate by logging in as...
It's a problem 118. Do you have 119, you said? Oh yeah, never mind.
You have to go and open melee games. Game 119 is the one I just created. Okay, I'll join this with a different user. So the melee mode is different in that every player can create tests and mutants. And the idea is, so we're experimenting with this. My software testing course started 2 weeks ago, and we're going to start using Code Defenders next week. I want to use this. The change is now that oh yes, for those where it did work, I used first name as username and password, but for most of them it rejected it. But you can use demo 1, 2, 3, 4, 5, and password was demo 1, 2, 3. Demo 1, 2, 3, 4. So for the melee mode, because students generally said that they prefer playing as, they learn more from playing as a defender and less from playing as an attacker, you can play as an attacker and as a defender, with the difference that your own tests cannot detect your own mutants. This is why there's this toggle here where you can switch between seeing the test coverage of your own test versus the coverage of the tests of other people. Okay, so I'll get this started by creating some test cases. It's a very simple class, so I hope it shouldn't be too difficult to think of things to test. Okay, great. Ben has created a mutant. Well done, Ben. So I'll attempt killing Ben's mutant by adding, I don't know, 11 riders and then asserting that there's 10 riders because that is the limit. Did I get it? He's not saying. Okay, I did not succeed in killing Ben's mutant, which is unfortunate because now Ben gained a point. Well done, Ben. Okay. What else could it be, Ben? Feel free to ask me any questions while I'm trying to get this mutant. What else could I test? I have no idea. Oh, maybe this is something to point out. There are certain rules about what is allowed in the mutants and what is allowed in the test cases. So for example, to avoid that every test case contains a list of 200 assertions, checking every single aspect, which you would never do as a developer, you can specify a maximum number of assertions you allow in a test. By default, there's only 2 assertions you can write. Similarly, you cannot include conditional statements or loops in test cases. And then if you mutate the source code, there's also rules. Let's see if my test, still not. Okay, I'll just make Ben suffer in that case. Okay, now Ben has to prove it's not equivalent. The mutant restrictions are described in here. So the default is moderate, which means that you can't mutate code comments. You can't add new control structures through logical operators, ternary operators, so new controls or new if conditions. Because if you can, it's very easy to create mutants that are just impossible to guess. Right? You could simply create a mutant that says if input value is some arbitrary number, and then a tester would never, ever be able to guess that number. We also added a strict mode, which adds even more restrictions because students tend to become very creative about what they want to do. Things like reflection or playing around with changes in method signatures and so on. I've actually changed this to defaulting to moderate in class because I've observed that the students who start messing around with reflection and whatnot, they tend to be the smartest students who simply grow a bit bored by competing against their fellow students, and they become very creative and do quite interesting things and can always learn something from what they actually do. So I default to moderate. Okay, so how's Ben's mutant doing? It is still flagged. Is struggling, Ben?
I'm just trying to work out. I think I might have made one that's equivalent. I'm not sure.
Aha.
I'm double checking.
Okay. We'll watch and see if it turns equivalent or if we get to see your killing test. We can view things that are happening. So in the overview, I get to see my actions on the left-hand side and what other people are doing. What else could I point out in here?
So if I submit a test, does it disappear or can I still?
Okay, so if you submit a test, it should appear in the list of tests.
Okay.
Is that you?
I have no.
Are you Whoosh?
Sorry? Yeah, that's.
Is that your use? Okay. So fishy. Your test is fishy because there's an open source tool that tries to detect test smells, which we've integrated. So if your test has certain smells, like in this case, the test smell detector says your test has assertion roulette smell, that's why the test is called fishy.
Was it rejected or was it put in?
It's there.
Get it? Yeah. Okay, it's flagged as fishy. What does it mean then?
Yes,
it's rejected or
no. So the test smell has no effect on the score.
Ah.
It's simply some feedback to tell them whether they've written nice tests or not. The only tests that are rejected are tests that don't compile, don't pass on the original version of the program, or violate the restrictions.
Okay. And then after you submit one, and then you need to make another one, no?
Exactly. You can produce as many mutants and tests as you wish. And well, you haven't scored any points yet.
Mm-hmm.
So we'll need to, what are you covering in your test?
I have no
Go
idea.
up.
Probably something. There is no way to get that one back and to repair it.
Well, you can view your test and you can submit a new test.
I get it.
Okay, so the melee mode might still have bugs. This is brand new and we haven't ever used it in production. So you're all my alpha testers now, or maybe beta, I don't know. If you find bugs or problems, or there's a conceptual problem with the melee mode, let me know. I just thought it's a nice way to try it out because you can play both as an attacker and a defender. Maybe one other thing to point out is that students can practice playing Code Defenders. We've created some puzzles, which are very simple game scenarios where they just have to do a single action. And they're organized on concepts of coverage. So for example, for a statement coverage puzzle, there's defender and attacker puzzles. For this particular puzzle, my aim is to produce a mutant in this particular line, which isn't covered yet because we're learning about statement coverage. So I can create a mutant in here, and then that puzzle is solved. I can move on to the next puzzle, which happens to be a defender puzzle. And again, this is one teaching me about statement coverage, and it says there's a mutant in line 7. So I would have to create a puzzle test case in which I assert that, I don't know, puzzle.bar42 equals 41 probably. It should be easy to detect, but it simply forces me to understand that I need to cover everything. Okay, so I've solved that puzzle. So I've now solved these two puzzles, and there's some more puzzles I can play in order to learn about statement coverage, branch coverage, or maybe some data flow testing. Okay. So if I monitor my game, I'm now player 2, of course. I can't monitor the game because I'm not the owner of the game. So I'll just play in that game and have a look if Ben has succeeded. So the mutant, when it's purple, then Ben has accepted, or he has lost. Either he has tried to detect the mutant with a test and failed, or he has simply clicked on accept equivalence. So that mutant is now accepted as equivalent. It's purple, and Ben has lost all the points for that mutant. So that mutant is now worth 0 points, which for the scoreboard means that Ben, well, he's lost 1 point. So he's still on top of everything. Okay, are there other questions? There are some other things I could very briefly show. It is possible to include classes that have dependencies. So for example, I think the options class had dependencies. So if I play my options game, there are other classes which are dependencies. Now, as an attacker, I cannot edit the dependency classes, only the class under test. But this allows me to include slightly more complex code. And in particular, what I tend to use it for is define some interfaces, but not provide actual concrete implementations. And then the defenders have to learn how to use mocking frameworks in order to produce mock instances of these interfaces. Okay, thanks, Alex. Okay. Are things happening? Demo 5 is catching up. Is there anything else you'd like me to show?
I'm just visiting your website, code-defenders.org. And I was wondering, is there any tutorial on what you just shown us, like in that website?
Okay, so there's 2 points, 2 sources of information. There's our GitHub page where you can find the source code. If you want to deploy it on your own machine, there's Docker stuff available, so it should be fairly easy, and that's documented well in the README. If you want to try it out, it's a virtual machine, which if you let me know ahead of time if you want to use it in class, it should be fine. It scales fine to about 30 students or so. But obviously, the more tests and mutants they create, the slower things get. So this is not a super powerful machine. There is some help here for help. Maybe slightly out of date. And I believe there is a short 10-minute demo video that is or will be available on the Impress website.
Okay.
For now, I believe that's all the information that is available. Besides papers describing the game, but that's probably, well, the 6 ESE paper describes it from the view of a teacher using it, so that there probably is some useful information in there on how to use it and deploy it in a classroom.
And one last question is, the whole thing is on mutation testing, correct? It's not on, with other testing? Well,
I mean, yes, it is based on mutation testing, and that defines the roles of attacker and defender. I tried to include other concepts such as mocking. Right, so after 3 or 4 weeks, I include classes where there's some external interfaces, and then they have to get accustomed to Mockito or other frameworks. Or, for example, I include certain assertion frameworks. So by default, you can also create Hamcrest assertions. There's also if you create a game, you can choose. I could demonstrate that maybe. You can choose to also, okay, not in here, only in the admin overview. If you create a game, now I know. It's no longer part of creating the game, but the class, you can choose whether you want to use JUnit 4 or 5, Hamcrest or Google Truth, if you want to use other external support libraries. One thing I'd like to include better is data flow. This currently is only included experimentally in terms of the puzzles, because we're still struggling to visualize data flow coverage. Right? Data flow coverage criteria have been around for a long time, and they're not used in practice because, and I think one of the main reasons is because nobody knows how to really visualize it. But this is something we are playing with. But other than that, it is based on mutation testing, because that is what the game principle itself is about.
Okay. Thank you very much. That was very nice, interesting.
Okay. Any other questions? Aha. Ben again. Tanya, do you want me to show something else, or have we reached the end of the session? You're muted.
Sorry.
Tanya,
No.
you're muted.
Yeah.
Yeah, sorry, I was talking. I forgot to unmute. I said, no, I think we, according to the agenda, we reached the end of the session. And I think we even went over it because we had to break before. And so no break. And well, it was really good. Meanwhile, I'm putting all this stuff also on the social media. So like Gordon said, there is a video which he made that explains it in a short video. So I just put this on the LinkedIn and on Twitter, so you can also look there, and it will also be on our website. So, and for any other more questions, you can always email us, and we can answer that too. I think we should go and continue with the next topic, the third result from Impress that we're going to show you. And this is the quiz tool. And I'm going to head over to Rui and Antonio.
Okay, so
send that one.
I'll start with a brief presentation about the topic, and then I'll hand over to Antonio for the demo. Let's see if I can share the screen. Okay, so this, as Tanya already mentioned, is about the use of quizzes as educational tools. And the motivation for that is that there's some evidence that you can use quiz to enrich the content of your classes and to engage students. So there are several kinds of uses we envision here. So for example, when introducing a topic in class, you can use quizzes to assess what the students know about the topic, and with that create some awareness of the students' own knowledge or lack of knowledge. It's quite interesting to use this as a reflection tool, and also as a tool to provoke ideas on the students to start a discussion on a topic. You can also use this to foster participation, get some attention in class as well. For example, in the beginning of the class, I often use quizzes to ask students about the topics of the previous classes to see if they still remember. And I use that as an opportunity to recover some of the topics. But we also envision this to be used out of class. And in this case, students will use the quizzes to study and to test themselves, to make some self-assessment on the topics they know or not. And the tool also envisions that we have materials, so examples of questions and quizzes that you can reuse. And in this sense, we want to reduce the efforts of teachers in the preparation of classes and evaluation and even tests in the end for summative testing. We have a paper discussing the motivation of the use of quizzes for software engineering education. In particular, we emphasize the use and the role of quizzes for self-regulated learning. So focusing more on the uses outside class. The paper will be presented on Tuesday at 2 on the feedback assessment and grading mechanism session. So feel free to go there. Jose will present the paper. So we have this demo. There's the link, and Antonio will show you the demo. I would just like to highlight that it's being used. We have lots of content there already. So it's being more than software and engineering because we open it for the university in general. So you can see that we have lots of questions. Quizzes that are generated are quizzes that the system creates automatically for the students on request. The quizzes that the teacher developed themselves, so they prepare some of them to be organized according to their goals, the number of students that were engaged in these courses, and the number of teachers. So you can use this as a team tool as well. So Antonio, I'll hand over to you. So we will run the demo and discuss several of these features that you can use and can show you some of the results as well. If you have any questions, of course, please. Antonio?
Okay. Hi, hello. I'm going to share the screen just to, okay, you got it. So I've published the link. You can experiment with the tool. Just a small introduction. So we are using it. In my case, I'm using. So I'm doing a flipped classroom teaching. So what I do is that basically I provide the material to the students prior to the class, and then during the class we just discuss. I don't do the formal presentation of the material, and at the end they know that they have a 5-minute quiz about what we discussed during the class. So it works quite well because actually the students will be engaged in the class because they know that they have the quiz at the end. And at the same time, what happens is that as you, over all these years, you have been preparing questions. So I have a database of questions that the students can use for self-assessment as well. So they can use the system just to answer questions about the different subjects and to do some self-assessment. On the other hand, the system is being used in classes, in software engineering classes, in the project of the class. So part of this code was developed not just by the students, because then you do code revision of the code, but so the system as well, because in software engineering, we teach the architecture of a web application. So there's a front end in Vue, uses the Spring Boot, GPA. So it's also a tool for learning. So, and the students get pretty involved because then they are developing software or developing components in a system that they are using for assessment and for self-assessment. Actually, the code is public source and it's available here. So, so it's a GitHub and everything is explained how you can install the system. And if you want to install it, then just send me an email and I can help you. Okay. Actually, we have videos how to install it because I prepared these videos for the classes so that the students can install the system and use it because they need to install it for the classes. So, but you can also use the current deployment in the system for the university because basically, as Rui said, we allow that all the courses at our university can use this. So this is the login with Phoenix. Basically, it's login through Out2 protocol with the login of the university. So if I go through this link, basically, I use the my authentication. And then what happens here, so I'm going to just show you. What happens here is that the system checks my credentials with the school and verifies all the courses I'm teaching or I taught in the past and allows me basically to do this. And as soon as I get here, I will get the list of my students that are enrolled in the course because also I get the students that are enrolled in the course. But probably I'll come back to this a little bit later. And another thing that we provide, we can create courses just for external people, and is through this login. Okay. But if you want to try, you can just try using some demo logins we provide. So you provide logins as a student, login as a new student, and login as a teacher, and login as an administrator. So you can experiment the system for all the different roles you can interact with the system. So what I'm going to show you is a little bit first of the type of functionalities we provide in terms of the teacher view. So I'm going to do a login as a demo teacher, but At the same time, you can demo the new student. Why a new student? So each one of you, if you go through this login will be a different student in the system. The reason because is that we do a lot of testing in the software engineering course. And when we try to do this end-to-end testing, it's relevant sometimes for each test, you generate a new student. So that's why we have these two types of login. So if you go through this login, everybody will be the same student. But if you go through this, we'll see a different, each one of you will be a different student. But first, I'm just going to show you the interface of a teacher. So this is a teacher of a special course that is the demo course, just for illustration. And basically what you can have, we have the questions. So we have one where I can create questions, okay? You can see here that the questions that already exist. So there are, I think, 10 questions here just in the demo. And these questions are multiple choice questions. So today we only allow multiple choice questions, but actually we are extending the system to allow other types of questions as well. And for these questions, you already know, you can associate with the question the topic of the question. So you can have several topics. So as soon as you can, for one question, you can add, you can add the topics. For instance, for this question, you can say architectural styles, okay? And a question can have several topics. And then you can say if the question is available, disable, or removed. Sometimes disabled, sometimes I disable question just because I haven't taught that subject yet. So I disable the questions, and I remove questions when there is some flaw with the question. So I remove it and I create a new one that is corrected, but it's kept in the system. And the reason because it's kept in the system, because we have the answers that were already provided to the question, and the number of quizzes where the question was used, and I have the difficulty level of the question. So the number of correct answers, the percentage of correct answers that are associated with the question. And to create a question is pretty simple. So if I have a new question and I have the title, I fill the question and I have the different options. I say what is the correct option, and basically I can add more options, and you can have, that's the type of interaction to create a question. So as soon as you have a question, another functionality that it's interesting is clarifications. What is clarifications? Is that when a student answers a question and then do not understand why it failed or why the correct answer is a particular option, he can just ask me through the system, I don't understand why this question, why this option is the correct option. I can answer him, and I can even decide to make my answer public, that everybody sees that. And so in the future, any student that answered that question can see all the public observations that I make, but only after he answered the question. So we can see, well, then I understand. So it's nice, and it's also nice because we can just, for instance, point to some point in the material where he needs to read about the reason why or what is the topic the question addresses. So this is the information about questions. Well, of course, we can add a figure to the question, but okay, an image. So this is that's the question interface. Then we have the topics. So these are the topics. I can create new topics, and I can see what are the questions that are available or removed that are associated with a particular topic. Another thing that we provide is the concept of assessment. And the concept of assessment is, this was necessary because in some point, we realized that there are questions that actually address several topics. And I need to decide which questions are available for the students for self-assessment. So we define these assessments to say, okay, so when I create a new assessment, I can say, I want to have all the questions that have these two topics. So I add them, and then I have one question in this situation, and all the questions that have these three topics, okay? And I have two questions. And then I can create a new assessment, okay? And okay, the order is 3, and now a new assessment will be available for the students, and I will show you the interface where you see the assessments that are available. So basically the assessments is a way to group topics so that I can just decide that since I teach, so there are, for instance, there are questions that only make sense at the end where I just taught several topics. So that's the way that's the way it works. Then another thing that I can have here is it's basically the students. I have my list of students, and for each student, I have the number of quizzes it generated and the percentage of correct answers. So I can have a little bit the status of the users that the students that use the system. And then I can see here some interfaces for other things. Oh, and I have the quizzes. Okay, this is the quizzes part. So how does my 5-minute quizzes work in class currently? Basically, I create a quiz, and I have several types of quiz. And now in class, for instance, I'm gonna add questions to the quiz. So I have, let's add 5 questions to the quiz. Okay. And I create a quiz with 5 questions. So quiz 2, and I'm gonna say that is available now. Okay. And I can say it's only through a code. So I provide the code to the students. So they access only the system using this code. And I say that is a one-way quiz. What is a one-way quiz? Since I'm doing this basically online, so the students are not even in the classroom, I prepare a quiz that is gonna take 5 minutes. They have 5 questions. The questions will be in different orders for each student. And once they answer a question, they cannot return. So that way I more or less reduce the probability that the students copy, okay? Or try to share the answers. And if I define that this timer, I just say when is gonna be the conclusion of this quiz. And I create this quiz, and then the quiz will be available to the students if I provide this code to them, okay? So you can use this code and you can answer the quiz. I have something, another thing that we can see in these quizzes is that I have the results of the quiz. So I can have, for each student, I can see what they answered, what are the answers that are correct and the ones that failed. And I can even export it, and it generates a zipped file. Let me see. And where I can just have, so it's easy to import. Okay, I have the results, I have the times they answered, and it's not in this case, but I even have a log of every interaction, every click they do in the interface. Currently, sometimes I use this log, basically just if a student tells me, hey, I didn't answer that, and I go to the log, but actually we are also using it to fraud detection. We have a student that now is doing a master thesis on fraud detection, looking at these logs and try to enforce some patterns of fraud in the log. So the idea here is just, well, in one sense, it's fun to do this type of master thesis, so it's something that is interesting. On the other hand, is that the teacher, my idea is that in the future I can have this, and just if we become suspicious about something, we just can talk with the student and ask him to go to a oral exam so that we can be sure about whether is answering, is not tricking us. Another thing that we do is that we can generate actually this is a set of macros, but is LaTeX, and then we can generate the quiz in using LaTeX. Okay, so but then you need to use a couple of macros that we have. So that was that part. I think that this covers most of it. There are two things here that I want to show you. One thing, but then will be with the demo, you interacting with me. One is submissions. We have a functionality where I can ask students to submit questions. So what I tell the student, okay, can you submit questions about this subject? They submit the question, and then it becomes a review process. I review the question till I say the question is okay. And if the question is okay, I just include the question in the database. Sometimes what I do, that's a way to get new questions, okay? And sometimes what I do is just I say, well, tomorrow is gonna have a quiz of 5 questions. One of them is one of the questions that you are going to submit. And then the students submit questions, and I just revise the questions, review the questions. If I approve the questions, I have more questions in the database, okay? And another thing is these discussions, so where I can have the interactions with the students, so we can interact about a particular question. So this is a question, and then the student who asks why this, and I can just reply and even make public a kind of. So it is this type of interaction, but we are going to experiment with it. And you also have tournaments. What is a tournament? Tournaments is we allow students to organize tournaments of questions. So they can just say, a student can say, I'm going to organize a tournament, and then informs the other students, and the students register, and then they can play with a tournament by answering multiple choice questions. So what I would suggest now is that I'm going to just give you a quick overview here. So, and then you can play with it, and I will play with the role of the teacher, and we can change roles. But so this is the view of the student. The student can basically answer a quiz. For instance, let me just pick the code of that quiz. So I have the quizzes here. So let's pick this code. Actually, I could also use this one. So they use the mobile phone or something, but both work. And with this code, basically what I'm gonna do, I'm gonna come here and I just introduce the code, okay? And I start answering the quiz. So as you see, so I answered this question, he asked me if I'm sure that if it's the answer, and I cannot return back. So that's the one-way quizzes, okay? So I go to the next one, I go to the next one, and then eventually I want to finish, and I end the quiz, okay? So when I end the quiz is submitted. I do not see the answers because it was not finished yet. So I only provide the answers at the end after the time, after the quiz. And to create the quizzes, they just come here and say, I want a quiz about requirements. And then with 5 questions, and they create a quiz. So, and it's very similar. And they can start answering, okay? The difference now is that when they finish answering, they will get automatic feedback about what they failed or not. And now, look, I didn't like this. And then I can ask the teacher why. Okay. And I submit it. And now the teacher on the other side will see these and can answer and can clarify. And that's the clarification process. Okay. Basically, we'll have an interaction between the student and the teacher about this question. Okay, so it's a way to learn because you can discuss this this way. So this is discussion. This part of the clarification is when I decide that one of the answers that I provide to a student should be something that I want to share with everybody. So I make this answer public, and then everyone that answers this question will see the clarification. So it's a way to enrich the more information. And the advantage of this is next year, I'm going to reuse the same question, and probably the same doubts will occur on the students, and so the clarifications are already there. Okay. So this is this part. Of course, they can see what are the ones that they have already solved. They can see the discussions that they have pending, and that's it. And this is for the scan. So if you use the other code, okay, the QR code, they can use it. I use it for a while, but sometimes there's always problems with devices and things like that. So then I just provide the code. Okay, it's easier. And then we have 2 others. Oh, we have the statistics. So the student can have a dashboard, with information about how many quizzes it solved, what is the percentage of correct answers. So you have this dashboard, and then you have the tournament, the submission part. In the submission part is the part where the student submits questions. So why? So you have a new submission, and so it's the same interface I have on the teacher side, but now the student is going to provide submit a question, okay? And let's say that this is the answer one, and I can even add a comment. This is about, okay? And I request review. So it's in the review, and then as a teacher, I can decide what to do, and I can show it to you. So basically, I came here as the teacher, and as the teacher, I'm gonna see to the submissions. I have this submission here done by this student. I can read the question. I can just see the question here, okay? And let's see, oh, this question is about, I can assign a topic to it, okay? And basically I can answer. I say, well, you know, you need to change something. And I write here what it needs to change. And I say, comment. When I say comment, okay, close. Now on the student side, oh, now I have a problem because I've done it with the new student, so I cannot get the same student anymore. Sorry for that. So I cannot see it here anymore. But I'm gonna reuse this student that actually is the same student. Request a review. Okay, I need to put a comment as well. I request a review, and then if I log out and I go as a teacher, now I'm gonna basically do it differently. So I have these two. So this is in review, and this is the new one. And basically I can just say, let's say that I approve it, okay? And as soon as I approve it, this question will become part of the database. So if I do this, now in my questions, not yet, submission. Sorry, I forgot to submit it. Yes, submit. Now it's approved, and now the question is there, and it's available in the database. But what usually occurs that I have several interactions with the students. Actually, in the future, I think that could be a way of assessment as well. So I've not decided to do it this year, but from next year, I use this flipped classroom. And so I may ask that every student needs to write one question prior to the class. So need to study the material, and I'm going to read the question, and I'm going to grade the question. So that way, I just try to enforce this flipped classroom approach, and so it's I think things become more. We'll have more interactions. I think that students will be more engaged in the process. And the final thing I want to show you is the tournament. So as a student, I can basically open tournaments. There's a tournament where it's already defined here, and I just can, for instance, join a tournament and solve the quiz. Okay, there was not enough questions for this topic, but I can come here and create a new tournament. And I say what is going to be the start time of the tournament, and the number of questions I'm going to say that is 5, and the available topics, I'm going to just add the topics here. Okay. Well, we have a problem. We have only 3 topics with this, so let's make it 3. And I think it's all. There must have start time, end time. Okay. End time. Okay. Save. And now I have the quiz here, and I can myself join the quiz. Okay. Actually, I think that was the one I created, and it's already closed because I probably off the date. Okay, I think this is the main functionality. You can do 2 things. In the first part, probably I can answer. If you have questions, I can answer the questions, and then we can play a little bit. You can just experiment using this interface. Oh, there's another functionality that's as an administrator where I can create courses, and by creating these courses, I can add. That's the way I add external people to courses. So basically, you can add the system, which is done through this interface. Here, okay, you have a login and a password that is assigned here. So, for instance, I've already assigned there, but for instance, just to give an idea, the way this works is that this is the traditional way. So if I add someone here, it will receive an email and with a link, and then authenticates and then creates a password. And so that's the typical way of registering in this type of systems. So I can show you a little bit. This is the same that Rui shown. So I go to this administration, and these are the courses. And for instance, I have selecting by the number of questions. Of course, this is used basically by myself. So in software architecture, we have 700 questions. Actually, this is in the different semesters. So we have information. Actually, the system exists since last year, but we imported all the questions from the past and the results of the students. And so we have data since 2010. Okay. And for software engineering, we have around 400 questions, and linguagens de programação, programming languages, this number of questions. So this is pretty much what we have in the system. Do you have questions? Something that no. So you can use it. I don't know if you want to play a little bit. So if each one of you go as a demo as a student, I can see you on the I can see your answers in the quiz on the other side, and I can see you even the log that we generate, which we register each selection of the student, the one we intend to use in the future for to detect fraud. So here for this quiz, okay, I only have one answer, but if you log in, I will see more answers here, and I can view the results here. Okay, what is interesting? So this is time that is left. But for instance, if I generate it now, it's going to be for a single student. But if I generate it, I will get something that is this log here. So look, that's what we are using. So I can see that this student click, so that the sequence of answers, the time, and that's what we are using for fraud detection. So we log everything that the user does. And okay, I think it's more fun. It's fun. Another thing, you have seen that already. So I can export this information. Actually, I can export all the questions for XML format and LaTeX, so that we can. Actually, we are not using now, but we probably we can implement export to a format, for instance, that can be imported to Kahoot or other type of systems. I don't know, Rui.
Let's see if people have questions or you can try it and see. We are nevertheless open to discuss this later, so you can leave you the link and can try it.
The link is in the link is in the chat, right?
Mm-hmm. It's on the website, and Tanya is sharing this as well.
Okay, the link is here, but I can.
So we are still assessing the results of the use. And in particular, what we want to study is the relationship between topics. We did some preliminary studies that didn't show exactly that the end results of the student is better, because we found a correlation, which is the students that perform better in the quizzes also perform better in the end exam, which is kind of expected in a way. So if they are good students, they are good through the semester in the end. But we are trying to see with this data if we can access connections between topics to see if they fail in one topic, then there's another topic that co-occurs with that one in the questions they fail. So this is actually information then that can be used to improve the system, so the questions and the quizzes we have in the system, but also to change the way you introduce the topic in class. So that there's might be a topic that students are not understanding and that you should invest more time in that. So this is behind the scenes, but once we have this kind of data, we can actually study a lot of things regarding the trajectories of students and classes within the topics and the difficulty as well. What are the questions that are more hard? This is based on success rates of answers. And this is what we're doing now as well. This is just to highlight that if you have this kind of data, you can study a lot of things and prepare better for the next classes.
Just as an example, this is last year students, they are anonymized. So at the end of the semester, we basically anonymize the information because we want to keep it for data science, just to do some inference of information, but we don't need to have the information about the particular student. But just this is software engineering 1 year ago, and I had students that I proposed 19 questions, but they answered 2,000
quizzes.
This is teacher quizzes, 90 quizzes, but they answered 2,000. They generated around 300 quizzes for self-assessment. So sometimes they just complain there's no more new questions, so they want to be sure that they answer all the questions. So it's a bit, but of course this also works because I just say, okay, I'm going to have an exam, and 20% of the questions in the exam are from these 700 questions. So then they try to answer the questions. But I think that by trying to answer the questions, they are learning basically.
But we actually can see here two kinds of students. So the first one explore the system a lot, but in the end, if you see the orange, is the quizzes that Antonio prepared. So this can be used for assessment. He didn't perform quite good. But in the second row, we have a guy that explored the system as well a lot, and he actually performed, had a good performance.
Yes.
So we can also identify these clusters of students, types of students, and see what are the topics they fail, and relate to the topics because well, these guys answered more than 2,000 questions, so they failed a lot as well. And this is kind of that we are trying to see. And we also exploring this as a tool to perform the exams as well, right, Antonio? Is there some things that we have to discuss internally?
That's the point where I'm not completely sure about the goal of the tool. What happens is that we thought this tool in terms of self-assessment and support to flipped classroom. So I think that this works for 5-minute quizzes at the end of the class. But then because of the pandemic crisis, we start using it for exams. But I'm not sure if this is the best way for a 1-hour exam, for instance, because then other issues. But actually, we had to do it. But the way I foresee the future of the tool is not in that direction, because I think.
Yeah, no, I agree.
I think it's more interesting from the point of view of these the students. So add more features that increase the engagement of the student, like the students submit questions or the tournaments. These kind of things, I think, at least differentiate from because there's a lot of tools as well to answer exams, and it's complex. Because one thing is that if I have so I have something like 24 or 26 lectures, so they need to answer 26 quizzes of 5 minutes, and this leaves me more confident about the results. Then they need to answer an exam in the tool for 1 hour.
Mm-hmm.
Because so But of course, it can be used for that as well. It's just I define the quiz and I define, instead of 5 minutes, I define.
Well, I agree with you that you can do it through time. So more every week or so, it could be useful.
Yes.
Either for summative, but also for formative evaluation.
Yeah.
Well, I don't know if you have more questions or ideas, so you can share with us. You can check the GitHub, participate, add new questions to the database, let us know.
Yes, and if you want to have students that can contribute or something, this is open source, and of course.
But I guess we are on time as well, Tanya, right?
Yes, I think we are. We can finish everything up. Thank you very much all for being here. Can you see my screen now? Because
I see.
yeah, because I just wanted to show you the places where you can find more information about our project. So this is our website. It's impress-project.eu. So on here we put all our presentations, events, publications, videos, and so on. And here you have this drop-down menu with the results, where you can read about all the results that we've also presented today. There is this LinkedIn page that some of you already got members here, and I already put like a video from Gordon here. And after this, I will also put a video here from the quiz tool, so you can look also here about our results. And there is the Twitter here, where I've also been putting some tweets on here about this tutorial. So you can always contact us here if you have any questions. And well, again, I want to thank you for being here, staying here until the bitter end. And I hope we can meet sometime, somewhere in real life.
Nice to meet you. Bye.
All right.
Bye, everybody.
Thank you very much.
I have in Brazil we say xará. Xará is a person with the same name. During all the presentation, I had a little bit confused. Tanya is my name too.
Yes, yes. How do you call this?
Yeah.
What was the word you said? A xará?
Xará in Portuguese. The same nickname or same name is xará.
Ah,
I don't know in English.
In Spanish, they call this a tocayo.
Tocayo, yeah.
So
okay.
yeah.
See you.
All right, see you.
Bye.
Okay, bye, everybody.
See you. Bye.
Bye.